Hey there, ladies and gentlemen. Welcome to lesson 9-6. We're getting towards the end of the school year here, so that's kind of fun stuff. Uh, lesson 9-6 is all about us being able to analyze functions. Here's the big questions of the day. Our goal is that you're going to be able to determine the type of functions based off of the patterns that you see or the graphs that you see. We also want to be able to create the different types of functions that we are going to see. So we have options here. So here's the rules that we're going to use. We are going to be using steps 1, 2, and 3. This is going to be the same order that you're going to be checking for things. If and only if we are given a table of values, we are going to be looking through step 1, step 2, step 3 to see if these things fit as to what we're looking for. So step 1 is to find out if the first differences of the y values are all equal. If this is true, that means that the data represents a linear function. Linear functions are written in that y equals mx plus b type of form. So if we find the first differences to be all the same, we've just found the slope. So our first differences are also equal to our slope. And that's an important thing for us to be able to plug in then and figure out what b is. If our first differences are not equal, but the second differences are equal, that data then shows us a quadratic function. Quadratic function is, what was that? A quadratic function is in this form, that ax squared plus bx plus c, but for us we're just going to use this one instead. The y equals ax squared. The plus bx plus c stuff is not going to be used for us. If neither of those things are working, if the first differences or the second differences are not going to be the same for us, then we're going to check for ratios. And we just recently learned about exponential functions, so this is going to be something that we can easily check for. That's when you take the second value divided by the first value and find out that the ratios are all the same. And if this is the case, then you have an exponential function, and exponential functions are then here. So if we find that the ratio is the same, that is what my b value is equal to, is whatever that ratio is. Now if you're given ordered pairs, all I gotta do is graph it. If it makes a nice straight line, it's linear. If it makes a U-shaped graph, it's it's a quadratic function. And if it's like going up very, very quickly or going down very, very quickly, but then never gets to be a certain number, then we have ourselves an exponential function. So that's what we got going for you, folks. We are going to show you a few examples. We'll try some things out, and hopefully this all makes wonderful sense to you. All right, let's roll. So step number 1 is to check our first differences. So here's our table of values. What I would like to do is check the differences from here to here, from here to here, from here to here, and from here to here. So you notice that 1 minus a negative 1 is 2. 3 minus a 1 is 2, 5 minus a 3 is 2, and 7 minus a 5 is 2. So my first difference is a 2. Now because all of those numbers are the same, I know that I have a linear equation that I can make out of this. So because this is linear, because it has a first differences being the same, I can now write it in the form of y equals mx plus b. Now my m is this first difference. So I know that I'm going to plug numbers in here. So my number that I'm going to plug in for the m is going to be 2. Now the next thing is I'm going to choose one of the points. For me, I think the smartest point to choose would be this 0, 3, and then just plug those numbers in for my equation. So in for x was 0, in for y is 3, and then at the end it says plus b. Now you could also have plugged this into point slope form because we have a slope and a point to make this equation happen fairly quickly as well. Now I can tell you though, because 2 times 0 makes a 0, we know that b is equal to 3. So that means that I know that I can plug in my b of 3 and then the slope of m of being a 2 to make my equation. So my equation, I better put it in red here, it's linear and it has an equation of y is equal to a 2x plus 3. So this would be my official answer. That's an ugly line. I'll try again. And did I say plus 3? I just erased some of it. There we go. And that's going to get us the information we have for a first difference linear equation. All right, let's check out another one. So on this particular problem, we are checking our differences. Having a calculator is always a wonderful idea. So I have 36 and 12. That's a difference of 12 minus 36 of a negative 24. And then we have this one being a negative 8. And then from here to here being, oh no, 2 and 2/3. So already telling that my second differences are also not going to work here because linear didn't work. They're all different numbers. Second differences are also not going to work because I have a fraction involved, so they can't be the same. So I know this is going to be an exponential. So I'm going to write down that it is exponential. What we should do now is check for the common ratio. So because this is exponential, we can find a common ratio, hopefully. So 12 out of 36. 4 out of 12 over 12, 4/3 over a 4, 4/9 over a 4/3. So if I simplify all of these things, I'm just going to use my calculator to simplify them. I get a 1/3, 1/3, 1/3, and a 1/3. That means my common ratio, my B, is equal to 1/3. So my form that we're using is y is equal to a times b to the x power. So I know that my b is 1/3. So I have y is equal to a times a 1/3 to the x power. Now we're going to plug in a number for x and for y to get our formula. So again, I like choosing the 0 one because that makes things easier for us, because I know that as soon as I have something to the 0 power, that this math is going to go a lot faster. So if I plug in a 0 and a 4 we had, so y is equal to 4, and then a times 1/3 to the 0 power. Now just this 1/3 of the 0 power is equal to 1, so that means that a is equal to 4. And if we have 4 is equal to a, I can now plug things in. So I have y is equal to a 4, and then times this 1/3 to the x power. And that would be my exponential function for this specific problem, because a was 4 and b was that common ratio of 1/3. And then all we would plug in is 4x to get our numbers. All right, here's one for you to try on your own. Your job is just to look for the pattern, choose if it's linear, quadratic, exponential. You don't even have to make an equation like I just did. So check that out. We'll go over this problem when you return to class. All right, here's another one, and this will be our last one other than your open response. All right, so let's check this one out. I know that this one is going down 7, down, holy cripes. See, 64 and an 8. That's going 56 away, so we're at a down 7, down 56, and then a even bigger number. Whoa! All right, so this is definitely not going to be linear. And this one is also definitely not going to be quadratic because the second differences are not going to be the same. They're huge. We're talking way bigger stuff. So we're dealing with an exponential function. Numbers are getting big very quickly, or small very quickly. So we're looking for exponential function. We're going to use the whole common ratio thing. So I have a negative 8 over a negative 1, which is a common ratio of times 8. So that means my b is equal to 8. So we did times 8, times 8, times 8, times 8 every single time. So into my formula, y is equal to an a times an 8 to the x power. We have to figure out what this a is equal to. So we're going to choose a number to plug in. Again, I like choosing where x is equal to 0. Makes things easier for us. So I have a negative 1. I wrote down negative y when I said negative 1. That's pretty silly. So we have a negative 1 is equal to an a times an 8 to the 0 power. I'm saying things but not writing them. 8 to the 0 power. 8 to the 0 power is just 1, so we're going to just call that 1. That means a is equal to a negative 1. So I'm going to have a negative 1 times this 8 to the x power. A more simplified way of saying this would be a negative 8 to the x power. So y is equal to that. That would be the most simplified way of writing this. All right, folks, this is what it looks like for exponential functions. And here's the equation that goes along with it. We have just one more problem that I'd like you to check out. We'll talk about this one when you return to class, but I think that my ugly mug might be in the way. So I'm going to move this down. Let me see if I can do this the right way. Oh boy, oh boy, oh boy. Yeah, now we can read. All right, so that information is now available for you to read. Check it out, give your answer. We'll talk about it when you return to class. All right, folks, this is the Burma Nation. We're signing off. Have a wonderful rest of your day.